All right. Good morning and good to see, or good night, whenever you're watching this. Good to see you all. We were here with another video. We're going to talk about inverse function notation. It's going to be a short and simple one. So let's start with a joke. How do you make a tissue dance? You put a little boogie in it. Oh, boogie, boogie, boogie. Okay. So today, like I said, you guys do hopefully remember what inverse functions was. And so all we're going to do is we're going to look at, I guess, what happens when we start to talk about the notation and just a couple things to look out for. I don't think my screen is sharing. Let's try one more time. If this doesn't work, I'm going to restart. There we go. Cool. We're good. We're good. Okay. So inverse function notation. Right now, in the same way that we only use the notation fx when a relation is one-to-one, or in other words, it passes the vertical line test, we're only going to use f of negative 1x when the inverse is also one-to-one. Right? So that means when these are both functions. And so we've got these identity functions here below, and it just means that if we take, if a function takes the inverse, it's going to end up with x. And if we take the inverse and then we substitute in our function, we're going to end up with x, right? It's kind of like why our inverse is reflected across the y equals x line. Now, these are called our identity functions. It just means that if we were to take the inverse of a function, it will end up with x. That's all it's trying to say. Now, there is a couple things to note here. This is the big one, notation. If it's f negative 1x, that's how you know it's an inverse. But if I have fx and then all of that is in a bracket to the power of negative 1, I'm talking about the reciprocal. Okay, very similar, but different. Okay, now let's have a go at this question here. So it says here, find inverse function for fx equals to x to the power of 3 and verify the identity functions. So let's just work with this. If I've got, in a sense, I'm talking about y equals x to the power of 3. To find the inverse, what do? All we do is we swap. So it becomes x equals to y cubed, but then we want to take the cube root of each because I want it in the form of y equals, and that there would be our inverse function. Or in other words, fx would be the cube root of x. Now, the cube root is a one-to-one function, so I can write it as fx. I don't have to write it as y. Okay. Now, if I want to verify the identity functions, all I'm trying to say is if I take f of, or let's do this one. Yeah. I can pick either one. For this case, I'm just going to pick this one. So I'm going to take the inverse function, and I'm going to substitute in my original function. So let's see what happens. That's going to give us, well, it's going to be the cube root. And instead of x, I'm going to put in what my original function was, which was x to the power of 3. And guess what? If it's x cubed and I take the cube root, it's just going to be x. We're verified. We're all good. Okay. There you go. So let's move on. Okay. Now, what we can often do as well is restrict the domain so that the inverse is a function. So let's just take a look here and let me quickly draw what is actually going on. So we have this y equals x squared. It's going to look a little bit like this. And so if we were to reflect it against the y equals x, it will end up looking like this. Right, hopefully you remember, kind of looks a little bit like this. Goes this way, goes that way. Now, if I take a look here, my green inverse function here, f inverse of x, that is definitely not a function, right? To make it a function, what I'd need to do is I'd need to get rid of this line here. So I'm going to make it as if it was dotted. Right? If I got rid of this bottom half here, now I'm dealing with a function. And this part here is actually a reflection of this part of the function here. So for me to be able to make this into a function, I could either choose to, I guess, delete what happens on the right-hand side or delete what happens on the left-hand side. And so I can restrict the domain by saying, okay, x has to be greater than 0, or I could stick by restricting the domain to saying x has to be less than 0, and then I'll just be left with, I guess, what's on the bottom. Okay, so that's what I can do. I can restrict the domain to whatever I want, just so I've got a function rather than a relation. Sometimes it's helpful. So that's kind of what this topic is about. Hopefully that makes a little bit of sense and helps with the exercises. I'll catch you guys later. Enjoy. Bye-bye.